Hello, boys and girls. So, another episode of Chemistry at Burbank High School. Okay, so we've been studying the 5 types of reactions. So this is a lab that we do in class, and this lab is a demonstration of a synthesis reaction. And what we're going to do is we're going to take a piece of solid magnesium, right? It's like this nice shiny strip here. So solid magnesium, and we're going to burn it in oxygen from the air, and it will synthesize magnesium oxide. Okay? All right. Now, in a high-tech lab, this would be very controlled. They would do this in like a sealed container and pump the oxygen through a tube, and so there'd be no impurities, and all the magnesium oxide solid, which is just ash, would be collected. Unfortunately, we don't have that type of equipment, so we're basically just going to barbecue the magnesium real quick. And the ash, we're going to try to get as much of the ash in the crucible as we can, and then weigh it. But when we do the calculations later on, and we check for accuracy, we're probably not going to get a good percent error on this one, right?
Okay, now.
All right, so this is the crucible and the lid that we're going to collect the ash in. Okay, and we got to weigh that empty also. If you look down here, we got to measure the mass of the empty crucible and lid. So why don't we get that out of the way right now? Okay, so we'll turn on the scale. Okay. Of course, let's zero it out to make sure there's nothing unwanted on the weight. And then let's just weigh the crucible and lid, and it's 24.39 grams. So I'm gonna write that in. Okay. It says 3.7 now, but again, that last digit is what, children? Estimated, right? So actually, let me change it to 3.5. Okay, so these electronic balances are called, the term that chemists use and engineers use is that this scale is significant to the hundredths place, right? Meaning the hundredths place is the estimated digit. The scale actually is not quite sure about the hundredths place, right? Okay. So we wait. Oh, we're gonna need it again. Turn that back on. Okay. So we got our weight of our empty crucible and lid. We're gonna set it up. Okay. Now let's weigh the length of our magnesium in centimeters. Okay. All right. And again, my eyes are getting old. Okay. All right. So I got to estimate it, right? Because each line on here is 1/10 of a centimeter. So we got to estimate it to the hundredths. And I would say it's about 15.34. That would be my estimation. Okay? So I'm going to put 15.34 centimeters there. Okay. And then it says burn the magnesium strip over the crucible shown by your teacher. So I'm going to do that. After the magnesium strip has completely burned, let the ash sit in the crucible, put the lid on it, and cook for about 5 minutes. Okay, and then we'll take some observations. We'll talk about the observations in class. And then we simply got to weigh the crucible, lid, and magnesium oxide, right, the ash at the end. And as long as the crucible, lid, and the ash weigh more than the empty crucible and lid, we consider this lab a success because we're not very accurate or precise in this lab. Okay? All right, so here we go. Let me burn this, and this will initiate the reaction. Okay. Got my tongs. Oh, let's light up the Bunsen burner. I saw your matches in here, Mr. I1, right?
Yeah, other drawer.
Other drawer.
Next one.
Oh, tons of matches.
Yeah.
All right, so we got the Bunsen burner going. Let's open this up. See this tower right here? Open that up a little bit until you get a nice pointy flame. Now, I tell my students to do it this way. I've discovered that this way works the best, right? So, you gotta wear goggles in this lab, right? Most labs you gotta wear goggles. Ready? So you put the thing over here, and watch, you're gonna get a nice surprise. Hold your Bunsen burner, and ah! Oh my God! Don't panic. Ah! It's just ah! I don't know why I keep doing that. Ah! Oh. All right. So the reaction is going on right now, and it's pretty much done. That was the reaction. Okay. Maybe get this here. See, and you see that magnesium oxide, right? That ash. Okay, and I'm going to just cook it really good. Okay, it's flared up. Now I'm going to just drop as much as I can in there. And you can see it's all broken up, ashy magnesium. Okay, and what we're going to do is we're going to cook it underneath just to make sure all the magnesiums convert to MgO. So we're going to put the lid on it. Okay, you see Mr. Arlen there. Okay. You need those tongs for the lid when you're ready. Okay. Ah. Oops, no, it's my fault. I touched it. Always pay attention, kiddies. Show students. Sorry, you're not. Okay, so you just let it cook now for 5 minutes. So we're probably just gonna, we'll come back in 5 minutes. In other words. All right. Okay, so we're running.
Yeah.
All right, so we're letting it cool down. It's still too hot to touch. When we can grab it with our hands, we'll weigh it on the scale. I'm gonna take this off. I'm gonna take this off, and you can see again, you just got a bunch of ashy magnesium. All right, it's kind of a white powder.
Okay.
All right. And
let's see it again. I did a very good shot. Let's see. Come on. Okay. Yeah.
All right. And also, you can see some of the MgO on the end of the tongs here, that white powdery stuff. Okay. So again, this lab, in a real high-tech lab, if they were doing serious research on magnesium oxide, they would do this reaction in a closed container, so none of the MgO escaped. But when you guys saw the smoke coming up, that was magnesium oxide escaping. There's magnesium oxide here that kind of fell around the crucible. So we're not going to get a good % error on this lab, but that's okay. We didn't expect it. All right, it was just mainly to show you that it's a fun lab. All right, so where are we at here? Not quite yet. Okay, while we're waiting, if you look at the lab handout here, right, it says mass of magnesium strip in grams per meter from your instructor. Okay, so that's on the board right here. It's 1.681 grams per meter. What my TA did last year is he took a meter of this magnesium, measured it out, clipped a meter's length of it, and then weighed it, and that's how much it weighs. So we're going to use this as the ratio to find, well, you'll see when we do the calculations. Okay? All right, boys and girls. Now it's cool to the touch. I put the lid back on. Let's weigh it. And as long as it weighs more than the empty crucible and lid, we consider it a success. All right, so what do we got? The empty crucible and lid was 24.35. This is 24.62, so success. Okay, so 24.62. So we collected 0.27 grams of that magnesium oxide. Okay, so if you want to look real quick, there's the empty crucible and lid, and here's the one with the magnesium oxide in it. Okay? All right, and that lab will do the calculations later on. Okay? And thanks again for watching, and we will see you next time.